Your phone and computer rely on tiny switches made of special materials called semiconductors. Today, we will learn what a semiconductor is and how we can control its electrical flow. First, we will compare materials. Then we will study pure silicon. And finally we will master the process of doping. To understand semiconductors, we first look at how materials carry electricity based on energy bands. Materials have electron energy zones called the valence band and the conduction band. In the valence band, electrons are fixed, but in the conduction band, they move freely as current. Good conductors, like copper, have overlapping bands, so electrons move easily. Insulators, like rubber, have a very large energy gap between the bands, blocking flow completely. Semiconductors fall in the middle because they have a small energy gap. Pure silicon or germanium is called an intrinsic semiconductor. At room temperature, some energy excites a few electrons across the small gap. When an electron leaves the valence band, it leaves behind an empty space called a hole. Both the free electron and the hole can carry current, but they do not do it very efficiently. We must add impurities in a process called doping to control conductivity precisely. Doping creates extrinsic semiconductors, which are much more useful for electronics. We can create an N-type semiconductor by adding atoms with 5 valence electrons like phosphorus. Since the silicon only needs 4 electrons, the 5th electron is left free to conduct current. In N-type material, the negative charge carriers or electrons are the majority. Conversely, we create P-type material by adding atoms with only 3 valence electrons like boron. This atom creates a permanent empty space or hole in the crystal structure. In P-type material, the positive charge carriers or holes are the majority. Let us quickly check your understanding of majority carriers. If a semiconductor is doped with phosphorus, what is the majority carrier type? Since phosphorus is 5-valent, it adds extra electrons, making electrons the majority carriers. This control over both positive and negative carriers is the key idea of doping. We learned that semiconductors bridge the gap between conductors and insulators. By carefully controlling doping, we decide whether current is carried by electrons or holes. This precise control allows us to build powerful devices like diodes and transistors. Mastering these fundamental building blocks is the first step toward understanding all modern electronics. Generate your own educational videos for free at eduvids.vercel.app.